Okay, so we're going to keep going with the anaerobic and resistance training by talking about energy system adaptations. And this is going to be really short, but it's important. So here are the two outcomes that we have for this one. And so when we're talking about anaerobic and resistance training, we're really focusing on two systems. And those two systems are the ATP PCR system as well as glycolytic. So there is some evidence, and this figure is right out of your book, but there's some evidence to suggest that with anaerobic or resisting training, we might have storage, or we might increase the storage of phosphocreatine. Now, this is important because if we've got increased phosphocreatine, then we're going to be able to take advantage of that ATP PCR system by allowing us to create more ATP during those short, high-intensity bouts of exercise. However, in order for us to take advantage of this, we need to increase enzyme activity. So yes, we might have storage, but it's not clear as to whether or not the enzyme activity increases. And since we need both, it's unclear as to how resistance training can affect this system. Now, with glycolysis, it's a little bit different. So there's three enzymes that are important with glycolysis. We've mentioned one before. We mentioned how phosphofructokinase, so this one right here, how that's kind of the rate-limiting enzyme for glycolysis. We've also got phosphorylase and lactate dehydrogenase. And so by increasing these enzymes, this could increase glycolytic capacity. And so what we have here is we could end up with greater force production, but notice that fatigue happens to the same rate. So notice we have greater force after training compared to where we started. So here is where we start training, or here is at the end of training, here is where we were before the start of training. Notice that we decrease that force production to the same rate. And so there's evidence out there to suggest that increase in power production is due to strength gains, so like muscle and neural adaptations, not anything to do with ATP. And so we're going to keep it really brief with these two systems, but I at least wanted to mention that that's what's going on.